Welcome to today's class on carboxylic acid, H.Sc. second year, and I am going to discuss about the chemical properties of carboxylic acids. And today's small part is acidic behavior, acidic order of different type of carboxylic acids. So here I will just show you a different type of the different patterns of arranging acidity which were appeared in different entrance exams, and I have just assembled all the questions of different entrance exam in one place, and I will explain each one by one. So first of all, before starting this, just let me explain just on what factors the acidity increase or decrease. There are two factors for pattern 1. Is type of two factors. One is plus I effect and other is minus I effect. So minus I effect is generally concerned with nitro group or halogen group if it is attached with the chain carboxylic group in the acid chain. If these things are attached, these are called minus I group, and plus I group, it is alkyl group. So if the alkyl groups, if the number of alkyl part is more, so more is the plus I effect, or if the change of the alkyl group is more, it is more, the plus I effect is more. So now what is the relation? If the minus effect is there in the acid chain, then the acidity will increase, and if plus I group is attached with the acid chain, acidity will decrease, because finally carboxylic acid, the acidity depends upon this hydrogen. If some factors which facilitate the release of hydrogen very fast, then it will be strong acid, and if some factors does not facilitate the release of hydrogen as proton, then this will be weaker acid. So the negative or minus I effect will facilitate the release of hydrogen as proton fast. Hence minus I group, if attached atoms or group if attached in the carboxylic chain, acid chain, then it will enhance the acidity, and if there is plus I group attached to this one, then it will not facilitate the release. Then more the number of plus I group or the more the chain of the plus I group, then less will be its acidity. So this is the background. Now within a very short time we will start solving the questions. First one is CH2FC. Is it very simple? So these acids groups all are minus I group: fluorine, chlorine, bromine, iodine, and it is known to you, I need not explain, that the minus I effect of fluorine is more than chlorine, is more than bromine. So more the minus I effect, more stronger will be the acid. Am I right? So here fluorine, chlorine and bromine. So the order of minus I ability of minus I electron withdrawing ability of fluorine, chlorine, bromines are in this order. So more the electron minus I effect, more is the acidic effect, acidity. So the order is very simple, no complicated explanation is required. This is the first. Now the second one is, if you are asked to explain the acidity of such type, this is already asked in AI-EEE exam. AI-EEE, this question was asked. You are asked to find the acidic order of this species or this compound. You see, in all this compound there is chlorine, chlorine and chlorine, but the difference is in number of the chlorine. Here 3 chlorine, here 2 chlorine, here 1 chlorine. So more is the minus I group or atom attached with a single carbon, more is the acidity, more easily hydrogen will get out or release as proton, so more will be acidity. So the acidity of such type, such pattern can be explained on the basis of number of minus I group attached. More the number of minus I group, more is the acidity. So order is again very simple. Now third one is, so you see, this is the compound in which you are asked to explain the acidity or arrange, increasing or decreasing order of the acidity. Here it is very simple, because the minus I atom is halogen chlorine. That is, chlorine is the same in all the compound, but here the distance matters. It is in the highest carbon number 1, 2, 3, 4, 5. So fifth carbon, it is attached. It is fourth carbon. It is in first carbon. It is in third carbon. So you see, more the distance from COOH, minus group or atoms attached, more the distance from the COOH group, less is minus I effect. So this is least, and this is in 1, 2, 3 position. 1, 2, 3, 4. Yes, 1 to 3 position. It is a bit closer than this one, and it is in one position. It is much more closer than the previous one. So more the closer to COOH, more is the effect of minus I group, more is the acidic strength. So order is like this. Am I right? This question again asked in AI triple E. So next one is, here you see, this is formic acid, acetic acid, and propanoic acid. Am I right? You are asked to arrange in increasing or decreasing order of acidity. But here you see, besides this, we are getting CH3 and we are getting ethyl group. Am I right? This is methyl group, this is ethyl group. So the plus I effect, in the case here where there is no minus I effect, here there is plus I effect. So earlier at the very beginning I told you that plus I effect will make the acid weaker. So more the plus I groups, more the plus I effect, more weaker will be the acid. So CH3 and C2H5, it has got higher plus I effect. Higher plus I effect is the least acidic acid. So out of this one, this is more acidic than this one, because it is methyl and it is ethyl. Am I right? So if you compare these two, this is formic acid, this is acetic acid, there is no plus I group, there is no plus I group, hence its acidity is not affected, so it is more acidic. So formic acid is more acidic than acetic acid than propanoic acid. Next one is, here you see, fluorine, chromine and bromine are, earlier we have told you that minus I effect of fluorine, chromine, bromine and chlorine. Fluorine, chlorine, bromine is of this order. So if you just see here, this is fluorine and this is chlorine, this is bromine. So this is higher than this, and this will be the least because here plus I effect is there. So this is the least. So again, nothing to explain. It is a very simple one. Next one is, now you see, this question was again asked in AI triple E. Here you see plus I group. Am I right? So this is also plus I, this is minus I, this is plus I. So if you think of this, you see the number of plus I group is here more, and here there is number of CH3 group is 1. So more the plus I group, less is the acidity. If you compare these two, out of this we'll find number 4 is the least acidic and number 1 is the second position. Now come to this one. There is plus I and there is minus I, and minus I is the highest number, means 3F4. So no doubt it is highest. Now come to this one. What will be its position? Its position is second. So the order is like this. Its plus I effect is less. Next one is again, this question is asked in AI triple E. So this is the compound. You are asked which one has the least pKa value. And in my earlier classes, I told you that pK value is inversely proportional to acidity. Means if pK value is the highest, the acidity is the lowest. Means it is the weakest acid. So more the pK value, less is the acidity. Less the pK value, more is the acidity. So we are asked here, but Ka value is directly proportional to acidity. So dissociation constant of acid, mind that. Ka is directly proportional to acidity. More the value of Ka, more is the acidity. Sometimes it is also asked. And pK is inversely proportional to acidity. More the pK value, less is the acidity. So if the acidity is the strong, it will have less pK value. So you were asked the least pK value, means which one has the least pK value. This last pK value means the highest acidic, highly acidic. So you see there is plus I group, there is plus I group, there is plus I group. So we are not going to arrange there is one plus I group, there is two plus I group, this is ethyl group. Mind that all plus I group will tend to make the acid a weaker one. So out of this, there is no such plus I group is there. So it is the strongest acid. If it is the strongest acid, its pK value is the least. So answer is formic acid has least pK value. That question was asked in AI triple E. So this is all about the pattern 1. Now let us explain the pattern 2. So pattern 2 starts with all aromatic carboxylic acid. Am I right? So there is something to be mentioned here, that ortho, meta and para position, there are some effect. One is called ortho effect. Am I right? So before this, let me explain ortho effect, para effect and meta effect. So OH group and CH3 group or OCH3 group. Am I right? So maximum case there are these types of groups are substituent with the acid. If the benzoic acid, there is always benzoic acid, there is CH3 benzoic acid, there is a nitro group, benzoic acid, nitro group, benzoic acid, and this is another. So let me just a bit explain this one. So if as a substituent in benzoic acid, this is benzoic acid, am I right? In benzoic acid, this is benzoic acid. If anywhere there is OH or CH3, anywhere, ortho, meta, para, there is some effect. What is this effect I am telling? O, when there is a O, there is a two factor is linked to this one, O and O. Means this O has a lone pair and this O has a lone pair that can have some mesomeric effect. This lone pair electron will be involved in the resonance of the benzene's pi bond. Sigma and pi in alternate double bonds, there is a resonance with this, that is called M effect. Am I right? So it has got M effect, and so also since this is carbon and this is oxygen, this electronegativity is more than this one, so it can withdraw electron. This has minus I effect. Am I right? So for this type of groups where there is O, there is mesomeric effect and minus I effect. So if two effects come into play, so what's happened? If the mesomeric effect is more, then acidity is less, and if minus I effect is more, then acidity will increase. This is the fact. You just keep it in your mind. If mesomeric effect is prominent, then acid will be weak. If minus I effect is prominent, then acid will be stronger. Now, if both this plus, if when OH is present, it has both plus and minus. Now, which one will prominent? Whether minus I effect or plus M effect? Which one is prominent? If minus I prominence, then it will be stronger acid. If out of the fight, plus M or mesomeric effect, that is participation of this lone pair of electron with the benzene rings pi electron, if it's wins over the fight, then acidity will decrease. We'll explain it a bit later. Now, if CH3 group is there, it has only M effect. It involves in N effect due to hyperconjugation. You have got it. One bond, no bond becomes just this type of bond remains as no bond, and this bond electron is involved in the M effect with the benzene ring due to hyperconjugation. CH3 involved in mesomeric effect. It is known to you. Am I right? So there is no minus I effect, and if there is nitro, there is only I effect, minus I effect. So this is the things. Now what's happened along with OH? If OH is ortho, if it is ortho, this is meta and this is para. If OH is in ortho, there is called ortho effect. Means there is mesomeric effect. Means lone pair electron will participate in the delocalization of electron in the benzene ring, inside the benzene ring. So M effect, and so also there is minus I effect. Now which one is winnable? That depends upon when OH in ortho position, then its coplanarity will disturbed. Means when there is no H, all benzene and COOH are in the same plane. When they are same plane, there is resonance. The mesomeric effect will predominates. Resonance effect will predominates. But if there is OH groups in ortho position, then due to this is in different plane, and benzene and COOH in other planes. So there is difference in plane of these two. So coplanarity in the same plane, the disturbed. So whenever there is coplanarity is disturbed, so the resonance will be disrupted. The resonance will not be there. So this, when present in the ortho position, coplanarity disturbs, so mesomeric effect will disturb. So it will assume positive charge, and due to positive charge, it will withdraw electron. That is minus I effect will predominates. If minus I is predominates, then acidity will increase. Now in ortho position, that same things coplanarity disturbs, but what's happened? The OH group minus I effect is predominating, but it will come far away from this one. So its minus I effect will be a bit less. So it will be weaker in meta. But when this is in para position, again what's happened? It will be far distance away. Minus I effect will again less. Then its acidity will decrease. So this is the fact. Now let us explain one by one. You can understand. Just you see, this is ortho position, this is meta position, this is para position, and it has no OH groups attached to it. So and another thing, when there is benzene, you can explain it in another way also. You can write it in this way. Am I right? And OH is like this. OH is like this. So there is hydrogen bonding, and when there is hydrogen bonding, acidity will increase. So, but when it is in meta, there are less chances of intramolecular of hydrogen bonding. Acidity will a bit decrease. So due to its highest ortho effect, so its minus I effect will be tremendously more than its minus plus M effect. Lone pair of electron involvement in the resonance, it will be less because coplanarity is disturbed. So it is highest minus I effect is there. Again, it has also got minus I effect wins over plus M effect, but its distance is a bit more, hence it is less. Again, each distance again more, hence it is less, and hence there is no such. This is the list. So it is a very critical things. You can't explain it very easily. So minutely follow the explanation which I have explained at the very beginning. That ortho effect. Ortho effect means coplanarity disturbs. Means M effect is disturbed. M effect if a minus I effect is more, means O becomes OH of O becomes positive, so it will withdraw electron. More the withdrawing capacity, more is the acidity. Now you come to this one, methyl group, methyl group, methyl group. Am I right? Where there is methyl group, there is CH I group, plus I effect. It is plus I effect, and M effect. M effect is due to hyperconjugation. When it is in ortho, it is ortho effect. So it's M. It's due to disturbance of coplanarity in ortho effect, and that its M effect will be reduced. Coplanarity disturb, M effect will be reduced. So due to reduction of the M effect, mostly in the ortho position, it is highly acidic, or it's 1H. Earlier I have shown you 1H will make hydrogen bonding when it is in ortho position, so its acidity will be more. Now it has no such effect, then this is no CH3 effect is there. But here again CH3 which has M effect, but that M effect is, it is a bit far away, so it has got less effect. Am I right? But here it is in para position, its effect is more. So we see here it is in due to ortho effect, it is highest. Due to coplanarity disturbance, it is highest. Hence it is second. And in M group, here due to its ortho effect, due to disruptions of the coplanarity or hydrogen bonding, H of this and CO of this hydrogen bonding, it is highly acidic. So this benzoic acid does not have any CH3 group. It is in second position. It is in meta. Meta is the less prominent. Para is again prominent. So order is this. So next you come to nitro, benzoic and OCH3. Here nitro group only minus I effect is there. Electron withdrawing effect is there. So it withdraws the electron. So minus I effect is most prominent in the para position. So it is highly acidic. Now here M effect is there. So if M effect is there, it will be least acidic, but there is no M effect. So it is highest, it is second, it is least. So again come to this group. If it is in meta position, its minus I effect is prominent, so it is highest. Then in para position, minus I effect is highest, and next one is in meta position, it is less effective in meta position, minus I effect less. So the order is like this. Now if you come to this PHCOOH, means this is this PHCOOH means this benzene phenyl group is termed as PH. Orthonitro CHCOOH means again it is in ortho position. Nitro is ortho position, and here nitro is in para position. Here nitro is in meta position. So what is its order? Its order is, you see, this is in ortho position, minus I effect the highest. So if it is 1, if it is 2, if it is 3, if it is 4, so 2 is the highest. Am I right? Then you come to para and ortho, meta and para. So minus I effect in meta is more than, para is more than meta. So second is 3. Am I right? So we have got 2 and 3. Now out of these two, it is in meta, nitro group, electron withdrawing group, but there is no such electron withdrawing group there till the effect is less, but it has some effect. So next one is your 4. and the least one where there is no electron group is 1. So the order is like this. So this is all about the two types of pattern, where in pattern 1 I have assumed the acid, it is aliphatic, and in the pattern 2 I have assumed the all aromatic benzoic acid type, where there is CH3 group, where there is NO2 group, where there is OCH3 group in ortho, para and meta position. The ortho effect has been explained. With the help of this explanation, you can very easily arrange the acidity of an acid in increasing and decreasing order. Thanks a lot for watching the class. Hope you have got the class with utmost interest. In my next class, I will start with the new concept of new chapter practice set number, different number of practice sets with different topic. Please don't forget to subscribe the class and to remain updated.